Hello, everyone, and welcome to our webcast, Inventor Annotations with Jennifer McMillan. I will pass things over now to Jennifer. The floor is yours.
Hi, everyone, and welcome to our webcast today. My name is Jennifer McMillan, and I am an instructional design project manager with ASCENT. And then what I do with the ASCENT team is I manage all of the curriculum development for our Autodesk training guides. So I work with a team of developers that work on all the content that we publish for the Autodesk products. I myself personally am a mechanical engineer, and I work on the mechanical products. So Inventor is my mainstay. I work on that the majority of time. And more recently, we have gotten into the Fusion release of products, and I've also worked on the training guides for that as well. So today, the format of my presentation is going to be much like many of my others. It's going to involve PowerPoint presentations to describe things, and then I'll be flipping over into Inventor and actually demoing the software. As we usually do in all of these presentations, we're going to hold our questions till the end. So if you could type those into the chat panel as we go, we'll certainly try and address as many of those at the end of the presentation as we can. It's going to be about an hour presentation, and there's a lot to cover. So with that, we'll get started. So what I'm going to be focusing on in my presentation today is all of the new annotation tools that have been introduced in Inventor 2018. And these have been introduced to support the visual presentation of annotations in a 3D PDF format, and as well to support those customers that want to incorporate a model-based definition workflow. So we're going to look at covering how we create 3D annotations, so those being both 3D annotations as well as the GD&T annotations. And then at the end of the presentation, I will also spend a little bit of time just talking about the export tools that will enable you to then share those annotations outside of Inventor. 1 hour is not a long time to learn all this content, so if you want to continue your learning with these tools, I'd welcome you to look at Amazon and our ASCENT e-store, where we have published a new Autodesk Inventor book. It's called Working with 3D Annotations and Model-Based Definition. And that's about an 8-hour worth of content, but it'll definitely take you from, this introductory course into learning a lot more of the specifics that is available. So with that, I'm going to get started. In terms of why people would annotate, so, what type of customers would be looking at this functionality? So customers that would be looking at maybe incorporating a model-based definition workflow or process into their design environment. MBD is an industry term that refers basically to the process of creating all of your design information that's required to fully and accurately describe your model, and it's all stored directly in the design file. These annotations and supplement the use of your parametric design data to then fully define the model so that it can be manufactured directly from the 3D part. So by including all this annotation type information in your model, you're actually eliminating the need to create that 2D drawing for manufacturing. Some users might find that they don't want to eliminate that 3D or the 2D drawing creation, but they still want to use 3D annotations to view and share the design. So they may want to share them for verification purposes, that type of thing. And a good format for that is using a 3D PDF. So that's another export option that you have when you create your models and annotate them. So as you're preparing and you're thinking, okay, yes, I'm going to 3D annotate my model, some of the things you want to think about is, like always, you want to make sure that you're dimensioning and tolerancing your model as you go. So as you're creating your 3D geometry, you're actually doing it accurately. That model is basically controlling everything, so you want to make sure it's as accurate as possible. The other thing you want to think about as you're modeling is your design intent and how that model is going to then interact downstream. So is it going to be in a top-level assembly, and knowing how it's going to be assembled into a larger assembly, that type of thing is important to know when you look at creating your GD&T annotation. So this is all kind of things prior to annotating that you should think about. So now you've decided you want to. What's the interface? And this is, like I said, something brand new in 2018. Autodesk, I thought, has done a great job in terms of putting it all in a convenient location. So there's one single tab, as you can see here in my image on the top of the screen. It's called the Annotate tab, and basically it provides you all the options that you need. So just like any other tab, it's broken into panels with all of the commands grouped within them. So over the next few slides and in the presentation, I'm going to use this, but this is kind of the whole interface in terms of the annotation tools. Once you've actually created your annotations, you can see here on my model on the right-hand side, you can see that they're all added and they're displayed in 3D. And once they're added, they're actually listed in the model browser. So you can see I've got kind of two model browsers here with two different folders expanded. So it creates them and groups them in two folders, the Annotations folder as well as the Tolerance Features folder. And Tolerance Features, those are all the GD&T type annotations. And then the other Annotations folder are kind of the other ones that we'll call 3D annotations for now. Those are linear dimensions, whole notes, surface textures, and some general design notes. All of that stuff gets stored in the Annotations folder. And this is really handy. These folders only get added if you have 3D annotations incorporated. Lots of right-click type options, so a lot of commands still available in the context menu, so you can right-click right in the browser to access a bunch of commands, or right on the model to access commands. So as I was learning this tool, you know, as I said, the interface is quite easy. All the commands are available on the ribbon. There is a lot of commands that are available in the right-click menu. Sometimes I found that I couldn't find something, couldn't figure out what to do, and just by default I would start to right-click, and there was a lot of commands available there. So when in doubt, when you start creating things, do a right-click. There's a lot of commands available there. So I mentioned 3D annotations and GD&T kind of for lack of categorization or for better categorization. I'm going to break it into two types of annotations. 3D annotations are what I've got circled here. So there's a number of them that are grouped in this kind of classification. And then I'm going to talk about GD&T, which are our tolerance features, all the geometric type annotations. First off, I'm going to start with these 3D annotations. And we're going to start with just talking about dimension annotations. So dimensional annotations enable you to display and visually identify the exact size maybe of your features, locations, and acceptable tolerances for any of the selected geometry on your model. They can be created in two ways. So we talk about the parametric design side of the model where we created it right when we created all our features, our sketches, and built everything. So we can actually promote those dimensions up to and into 3D annotation, or you can create them. So using the dimension command right on the Annotate tab, as I've pointed out here, you can see that there's a dimension command, and I can create dimensions. And very much like creating dimensions in a sketch, you select entities and you place a dimension. Just like creating them in 2D drawings, you select faces, you select edges, that type of thing. You do the exact same thing in the annotation tool. And if you look at my my image of my model here, you can see I've got a few linear dimensions added. And those are all either promoted or created dimensions, and they appear the exact same way regardless. Surface finish is another type of annotation that you can add, and basically this is allowing you to describe a specific surface finish to a unique surface in the model. So here's an example here where I've created a surface annotation that talks about the maximum roughness value of 32. And so we're basically assigning a separate surface finish to that one surface in the model. Hole information, hole and thread note is another option, so you can see that's on the General Annotation tab. And this basically is creating, as I've shown here in the image, an annotation that describes how a hole is going to be manufactured. If it's a through hole, if there's any thread information, it would describe that as well. And all that information is being pulled from the parametric information inside the model and specifying it as a 3D annotation. And the last one here, modeling notes. These are the two options that are included here in the Notes panel. And these basically are available to provide additional modeling information in the form of a 3D annotation. So there's two types. One is a leader text. So just like you are familiar with in 2D drawings, it's doing the exact same thing. You're picking a reference on the model, you're selecting a selection point as to where you want to place it, and it's bringing up that format text dialog box to enter information on the model. General note is a bit different in the sense that it is just placing it on your graphics window, and it allows you just to enter text as well and describe kind of some additional modeling specifics, so maybe materials, tolerance values that might not otherwise be specified, that type of thing. So you can use that type of information. Before I get into the actual demonstrating inside of Inventor, what I want to mention is just the interface in terms of the creation. So they've done a really nice job of making it as consistent as possible. So in here I've got kind of 3 examples highlighted in different color boxes. If you look at the top, this in the black box, this is a dimension annotation. And what I want to show you here is basically highlight out the mini toolbar. This is the interface that they use to create all of your annotations, any type of annotation. It's using a mini toolbar. And above that mini toolbar is a preview display of what is being created. So if it's a dimension in this case, it shows the dimension value as well as tolerance. And then you can interface with these fields to change values, change the type of tolerance that's being set, that type of thing. If we look at the green box, this is a whole thread note, and you can see I've selected the inside surface of this hole. It immediately previews the annotation, but you want to focus your work on the mini toolbar initially until you've fully defined it. And you can go through, it recognizes automatically that it's a through hole. You can go in and add a tolerance value by selecting on the actual diameter, and it'll bring up a separate toolbar that looks actually very much like this one, where you would pick the tolerance type and add a value. So the third example here is this is a surface finish, and you can see, again, it's a mini toolbar. All of the interface is being done with this little floating mini toolbar, and you can select any of the options on that. You can select any of these fields, the A, B, C, and enter values for how you're going to define that surface texture. So what I wanted to show you here in this image is that it's the mini toolbar. That's what I really want to get across to you before we get into our demonstration. This is the model that I'm going to create in my demonstration. So I'm going to create a bunch of linear dimensions, created dimensions. I'm going to create some radial dimensions and diameter dimensions here, a whole thread note. I'm also going to create some text and a surface finish. Okay? So now I'll just flip over into Inventor, and we can get started. So as you can see here, I've just opened a model, pre-opened, so we don't waste time doing all of the opening. There's no annotations in it. You can see that those 2 folders that get created aren't here, so I haven't actually done anything in this model yet. So I can open my Annotate tab by selecting Annotate on the ribbon, and you can see all of those commands that will allow me to create my annotations are in here. I'm going to start with dimensions, so dimensional annotations. And I mentioned promoting and creating. I'm going to start with promoting. So if I hover my mouse over the sketch that was originally created to create the revolve, the base shape for this model, I can right-click on it and select visibility. So it turns on the display of my dimensions. These are all my sketch dimensions. And then all I have to do is go in here and promote. So as soon as I hit here, there's going to be a window or a message come up. So just so you know that I'm planning for this. What's being prompted here is it's asking for a standard. It's saying I need to ensure that there is an annotation standard assigned to the model, and is this the correct one? So yes, I actually do want this active standard set. I can click OK, and then it's set. So this is now my annotation has been added. It was promoted from the 15 sketch dimension. Now it is a 3D annotation in my model. I can do the same thing with, let's say, the 24 dimension, as well as a few others. I'm just going to promote these. Okay, and you can see I've promoted those. I'm going to turn to 3D to show you how they've added. You can say, I know you saw me promote that 50 dimension, but it's actually hidden inside the model. So that does happen. You can select it then and drag it out and reposition. You can actually move things around. I'm going to go back into 3D here, or sorry, into 2D, and show you I still have my sketch dimensions shown and my annotation shown. This 38 dimension here, this is actually one that I use to create my sketch, but let's say I don't want that for annotation purposes. I don't have to show it. So I'm going to turn off this visibility of the sketch, and now I'm simply seeing all of my annotations. Okay. You can see that I've created, or not I have, it automatically created this folder, the annotations folder over in my browser, as well as all of the dimensions. So now I'm going to create a dimension. So that 38 that I was in the sketch isn't the one I wanted. Let's say I want to create a different one to describe this model. I activate the dimension command, and I'm going to select surfaces. So this is just like you would dimension any other way. You select your references. Once 2 references are defined, you can drag out to position the actual 3D annotation. Now, this gray plane that you see, this is key, and this is key throughout every annotation that you're going to find, and this is called the annotation plane. I'm going to try and spin this a little so you can see how it's created here, or where it's placed. So it gets placed based on the selections I make when I select my references. So it may be just fine for you in terms of how you want to place that annotation, but it may not be either. You right-click, and you can actually get a lot of commands here in terms of how to change that plane. So we can select an annotation plane. We can also toggle between different default annotations planes. I want to select a plane. I actually want that plane to align with the annotations that I promoted. And those were lying on the actual sketch plane, which is my XZ plane. So I'm going to attach that there. So I actually selected that XZ plane, and then I can place my annotation. Now, when I spin, you can see that that annotation is actually on the same plane for consistency purposes. Now, here's my very first toolbar, mini toolbar. As I mentioned in my presentation, this is a toolbar you're going to see all the time. It may vary a little in terms of the information it's providing, but this is the interface for creating your annotations. With Promote, we just simply promoted them, so you don't actually see this. However, if you needed to ever edit those annotations, you would be brought back into this exact same mini toolbar. So I don't actually want to create any tolerances on this right now, so I'm just going to click the OK button, and you can see that it gets added. I can go in and modify positions on things and drag it around. So now I have 2 promoted dimensions and 1 created. At this point, they're just 3D annotations. It doesn't matter that they're promoted or created. What you're noticing is the precision is off on the different ones. So it was just that the precision in the sketch was different. I can go in and modify that. I can right-click on that annotation, change my precision, up in there, to 2 decimal places, precision, and there we go. Now we have more of a consistent look. Over in the annotations folder, I'm just going to mention, if you look at them, all of the 6 of them are identified as linear dimensions. So that's even those diameter dimensions are linear, and that's because they were pulled from the sketch. I actually don't want that. I want to actually create a diameter radial dimension where that's going to be indicated properly. So I'm going to delete these. So I can delete them by just clicking on them and hitting the delete key. I can also delete them directly from the model browser. So I'm deleting all 3 of those, so that I can recreate them to show you how we can select, create a nonlinear type of dimension annotation. So I'm going to select Create Dimension again, and this time I'm going to select the cylindrical surface. So this is going to create my radial and my diameter type annotations. You can see it's defaulting to radius. I actually want to change that to diameter, so I can go through and toggle that off just with right-click menus. I'm okay with this annotation plane, so I'm just going to select to place it. And you can see now that I'm back in my mini toolbar. So again, you're going to see these a lot. I can actually add a symmetric tolerance to this. So I'm going to choose my symmetric option. And here I'm going to enter a value. So I can't select in the preview, but I can select in the mini toolbar. So I'm selecting that .00 tolerance field. I'm going to change that using that new mini toolbar that just appeared. I can also change my precision if I wanted to, and click OK. And you can see how it's added the tolerance value. So I can go through and also, to mention the other two, I'm going to do the same thing, add a symmetric tolerance. And then thirdly, the last one, and add those three. So there I have now 3 created 3D annotations. One thing I do like is that I can change the orientation of this on the annotation plane. I can right-click, toggle alignment, so it flips it. I can do that for all 3 of them just to kind of change the orientation of that to be a little bit more what I want. And now I have all of those annotations. So we've promoted, we've created, and now what I want to do is flip to one of the other options, which is the surface finish. So we can select the surface texture annotation. And the first thing it needs me to do is pick a reference. So I'm going to pick right on my face. So the selection point when you define your annotation is key. So it's going to be the original or the default location for your leader lines, that type of thing. You can change that later, of course, but it's just if you want to pick, something close to where you want it, that is always handy. I mentioned about changing annotation plane, so that's the default one that's been chosen. I can right-click, I can select a different one, but I like this select next candidate plane, and the shortcut for this is the space bar. So I'm going to go over here and just use the space bar. You can't see me clicking that, but it toggles back and forth between the default options. So those are the 2 available right now. And I can place on that annotation plane. And here is my mini toolbar. One thing that you'll commonly find is that they appear over top of your geometry. If you select this little bar at the left head side of the mini toolbar, you can select and drag that around to reposition it in a more convenient spot. So I can go through and I can add things. I can change the actual default symbol that I want to use. I'm going to keep it with the basic surface texture symbol. I can add force a tail on it. I can add the majority symbol. I can mark it as all round. Just different ways you can do this. What I want to show you here is you can also pick on any of these fields. So this is the field that's going to allow me to enter my roughness average maximum value. So here I'm going to enter a value of 32. And I'm going to click OK. And I'm going to create my surface finish texture. And you can see how it's now added in the model browser over on the left-hand side. You can see it's there. And that gets assigned directly to that face that I selected. The next one is a whole thread node. So I can select and activate this whole thread node, and I can pick the surface of a hole. So here I'm going to select this hole. And you can see immediately it places it on the default annotation plane. And I'm fine with that plane. I'm good with that. I'm going to toggle the alignment, so it's going to flip it a little more to look like the other 3D dimension annotations. And I can place it. And when it places it, it recognizes that it's 7.5 in diameter, and it's a through-all hole. The one thing it doesn't recognize is that it's a member of a patterned circle. So that's something that is a limitation with just hole patterns, or sorry, the whole thread nodes. It is just recognizing that it's a single hole. I could go through and pick on that diameter value. I can add a tolerance type to it. I can set it as symmetric and change my value, let's say, to 0.02. And you can see how that updates. If I did want to incorporate the fact that it has 8 holes, what I can do is I can go in and edit this and add text. So it brings up the Format Text dialog box, and I can go in and enter information here. Unfortunately, it does not allow you to enter parametric information. So if you're familiar with this format text dialog box, these two lower fields here enable you to pull parametric data from the model. And as you can see, they're all grayed out, and this is not a possibility in this functionality right now. So hopefully that is something coming. So I'm going to select OK, and you can see how now my whole note is identifying that there are 8 holes, and it shows the values of those holes. So finally, we've talked about all of the general annotations, so the dimensions, the whole thread notes, the surface texture. I talked a bit about the 2 other 3D annotations that are text-based, first one being leader text. So we'll deal with that one now. So I've just selected the leader text option. And one of the first things that I noticed is that there is no 3D annotation for chamfer notes. So this is a bit of a workaround for incorporating notes on chamfers. So I've just activated the command. I'm going to pick an edge that was chamfered, and I'm just going to enter actual data myself. So I'm going to say there's 3 chamfers in this model, and I'm going to highlight the size of those. Now, I just from experience in working with this model, I know that that parameter value is D33, and I can set the precision on that parameter, and I can enter it. So it's basically pulling the parameter from the model to identify the size of this chamfer. I'm going to add that twice because it was a D by D chamfer. And I can select OK, and you can see how that is a note that now is an annotation added in my model indicating the chamfer sizes. So unlike that whole thread where I couldn't incorporate a parameter, I was able to create incorporate a parameter into leader text. And finally, general notes, and these were ones that I mentioned lie on the graphics plane. And you can see here I have to pick a quadrant on my graphics window. I'm going to pick the second quadrant here in the top left corner, and it brings up the Format Text dialog box. And I have copied and pasted from just a note box, so I didn't have to type it all in for you. But here's just my general note that I wanted to add, and I can click OK, and you can see how it's added to the sheet. It's not incorporated into the model. It doesn't rotate with the model, but it gives that additional information, in this case on the material and the tolerances for any dimensions that aren't specified. And that's where what I wanted to show you in terms of this first demonstration. So we focused on the general annotation options as well as those 2 notes that enable you to provide text-based information in your model. Now we're going to go back, into my presentation. And we're going to focus on the geometric annotations. And as I mentioned, these are the GD&T types of annotations that you'd want to add in your 3D model. So when you're designing in a 3D CAD modeling environment, all of that geometry is created perfectly. But then during the manufacturing stage, it's not as possible to achieve all that same perfection. So the goal with your geometric annotations is to indicate variations in size, feature locations, and orientations where they can't change, where they can't vary. You want to make sure that you're communicating that this information cannot vary when it's being manufactured. This is all done with the GD&T. This is a symbol-based system for tolerance control. It's not something Autodesk has developed. It's an international GD&T standard. It is governed by the NASME standard Y14.5M 1994, and it governs how all of these annotations should be added to clearly describe your model's design intent. In the section that I'm talking about now, and as well in our training guide that I mentioned is available, we focus only on explaining how to use tolerance feature command in Inventor. We don't talk about how you use GD&T. So it's just something I wanted to caution you on. It's not a GD&T course. It's teaching you how to use that tolerance feature command. With the other 3D annotations that we talked about, it was all based on mini toolbars, and this is exactly the same thing. The only thing is they get a little bit more complex. There's a few more options, a few more active cells to make you, to help you customize what you're getting in terms of the annotations, in terms of your datum reference frames and identifiers that you're creating, all that type of thing. When you go to create your very first tolerance feature, or any tolerance feature, you need to pick a reference. So the way that, or the type of reference you're picking, whether it's a planar surface, whether it's a cylindrical surface, it assumes what you're going to want to define in your GD&T. So it's a nice way to start things in terms of defining. You can always go down the road and customize and change things. So what's important there is knowing how to interface with that mini toolbar. So here I've just got an example of a reference that was up. It was a planar surface reference that was picked on my model. You can see that the planar surface option has been defined. And based on that reference, it's assumed that it's using the flatness tolerance type symbol. It's assigned a tolerance value of 2.0, and at the same time, it's created datum identifier A. It was the very first GD&T that was added in the model. And any of these fields are active. So let's say you didn't like or didn't want the flatness symbol to be used. You can select in that field. It's a live field, and it brings up this second mini toolbar that enables you to change them. Now, when you do the pull-down list here, what's really nice here, it actually refines the list of available symbols that are possible based on your reference selection. So you don't get the big long list that you have to pick through. It does only provide you with ones that are possible. The star that is adjacent to it is the default one that's being recommended for you. You can change the tolerance value. You can go over and select on that field. It opens the mini toolbar, and you can select that. You can turn off on and off whether or not the datum identifier is created, the datum reference frame is created, so that's a nice way to do it. You can also select whether or not you want to add additional notes. So lots of commands available here. I just talked about planar surfaces, but if you make a reference selection and it identifies that you're actually trying to describe a slab surface that's two planar planes, it's going to actually provide you with the diameter, not diameter, but the linear distance between the two planes, and it provides that in the form of a dimension on top of the datum reference frame. So we can go in and we can also assign symmetry and tolerances and enter the values just like for dimensions and do that. Again, you can decide whether or not you want to add or incorporate the use of that datum identifier and add additional notes. Another key one, and one that I'll be showing you in the demo, so I just wanted to briefly mention it, is hole references. So let's say you're going to pick a hole. That's the cylindrical surface of the hole. When you do so, it will recognize that it's a hole. So it's a simple hole, meaning that it's not involved in a pattern. It pulls up like this, and it shows you that it's a simple hole. It gives you all of the tolerance symbols. It gives you the values for the diameter and that type of thing. If it recognizes it's part of a pattern, it actually also provides the number of patterned holes which is in it. So when we spoke a few minutes ago and I showed you and told you about the hole notes, that it wasn't parametric. This is parametric, so it does recognize the number of holes, and it would update if you actually made a change to that in the model. If you needed to stack segments, you can use the Add Segment button. And if you need to, say, change the datum reference frame that's being referenced, you can select on, this is a live cell. You can go in and select a different one or create a new datum reference frame. So lots of options there. If you're trying to figure out what's live and what's, you can hover your mouse over them and they turn red, so you know that they're editable options inside of the preview. So we've created a bunch of tolerances, or GD&T annotations in your model. Autodesk has provided something called the Tolerance Advisor, and this is available inside of the tool, and it basically is a constant check of the annotations that you're creating, the GD&T annotations, not the dimensional ones. So it's providing messages and warnings that are helping you to kind of progress through your GD&T annotation of the model. You can see it looks like this. I've got the image. Provides informational messages. So this I symbol, it's informational. So it's not a failure or anything. It's just that, hey, this is information that this datum reference frame has not been referenced. There are also, you know, indications of warnings where it says a tolerance might not be completed. So it's just really guiding you in terms of your annotations throughout the model. And as you add more and more, some of them clear up, some of them you might add more. One of the things I find most convenient is to have that open all the time so that as you add them, you'll start seeing errors so that you're not leaving it to the end when you've added multiple annotations and you have to figure out all of the problems. And then the last type of annotation is called a general profile note. And this is where you're assigning a profile tolerance for any face that you don't explicitly have a tolerance feature actually assigned. So again, much like the general note that we added where it gave some additional information, it also lies directly on the graphics window and provides you with information on what that general profile value is. So now we're going to flip back over into Inventor, and we're going to open a different model so we can annotate this one. And we're going to focus only on the tolerance feature option. So we can go over into the Annotate tab. Before I get started, I just want to show you, remember when we started our annotation in the previous model? As soon as I tried to create an annotation, I got a message that came up and it said that I needed to define the annotation standard. This can be done also using your document settings. So you can go into Tools, Document Settings, and you can define it this way. So this field here, Annotations, and you can select your active standard. And this one is Imperial, so I'm just going to leave it with this standard and click OK. Okay, so it's just a different way to get in there and do that if you wanted without having to get that error message come up as soon as you create your first annotation. So I'm going to go back to the Annotate tab, and we're going to create our first tolerance feature. I'm going to select the tolerance feature option on the geometric annotation panel. I'm going to rotate my model a little bit so that I can pick my bottom face. And this is going to be the very first plane. It's a plane that I would mate up against another model. So I'm going to annotate this one first. And I'm going to select that plane. And my mini toolbar appears, you can see. And it's knowing that I want to create a planar surface annotation based on the reference selection I made. I can pull that down. So let's say the assumption wasn't correct and I actually wanted to create it as a slab. You can see how it then grabs the parallel surface above it to reference. I don't actually want that. I actually do want a planar surface. I'm going to go back and leave that on and click OK. And then it's going to prompt me for my annotation plane. So we did this with all of the other general annotations we created. It immediately prompts you with a default annotation plane. I can use the space bar to toggle between the two. I can, let's say, leave that. And that's all relative as well to where I picked, where I selected that surface. So I'm going to just place that. And you can see now that I have my mini toolbar. So just like every other mini toolbar, all of these fields are active, so I can highlight this one, I can select it. It brings up the new mini toolbar, and I can go in and I can change it if I want to. I do want to leave the flatness tolerance symbol, so that one is fine. And I could go in as well and change my value if I wanted to. I'm fine with that tolerance value, so again, I'm not going to change that. Excuse me. And I can go in then and just click OK. So we're good with all of this, and I have my annotation. I can go over now. You can see that it's added this tolerance features folder. And if I expand this out, I just want to highlight kind of what it does when it creates this. It's always good to understand this model browser. So if I highlight over the planar surface, it shows that that's the surface that I have annotated. It's highlighting the feature control frame. So over on my model, you can see that it is showing that feature control frame. It identifies that this was datum identifier A, and it also created for me, for future use, a datum reference frame that I can use in creating my next annotation. And if I look at my tolerance advisor, that comes up immediately as soon as I placed my annotation and accepted it. It's right now it's really giving me no warnings. It's giving me some informational data. It's showing that this datum A has not been referenced, which we know because it just was created. And then additionally, there's a couple other informations here saying that not all degrees of freedom are constrained, and there's some surfaces that are unconstrained. And we're okay, we know that as well. We're just getting started, so I'm fine with leaving that advisor as is. And I'm going to create a second one. So in creating my second one, I'm actually going to define the position of these holes on the face that it's going to be mating up against. So when I select those holes, it is pretty smart, and it realized that it was a hole that belonged to a pattern. If I wanted to go back, I could choose to annotate the simple hole, but I do want to accept that it's going to be dealing with the pattern. Select OK, and then I can place it. It has assigned a default annotation plane. I'm good with it. We're going to add that. I can move my my mini toolbar over a little bit so I can see everything. So we can go through. What it's done is created this datum identifier B. I've got a default positional tolerance symbol that's been assigned with a tolerance value of 0.08 on that on the diameters. And it's also recognizing that it's a member of that pattern. So it's showing that it's 4 of them with 0.47 diameter. And I can go through and make any changes. So let's just show how some of these fields are live. So let's pick the diameter here. And what I want to show you here is that I can actually deal with the material condition, and I can add the maximum material condition symbol so that that is added into my my GD&T. I can also maybe change the tolerance value to, let's say, deviation. I haven't done that one. I want to add that, change my value for the upper as 0.008 and the bottom 0.003. And you can see how that's manipulated my annotation. I'm going to leave positional. I'm fine with it referencing the datum identifier A, so we're good there. And we can create it. So I select OK. So now I have my second one. If I go over into my browser, I can compress this first one. And now if I expand this out, you can see that it's got all 4 holes associated with it. It's got a hole note. So that's the 4 times, and it shows the tolerance on those holes, the feature control frame, and that it created datum identifier B with it. And then as well, with that, it generated a new datum reference frame. Okay, so we can also use that. So now my tolerance advisor has updated a little bit. It took out that the degrees of freedom have now been constrained. Great. But I still do see that one of my datum references has not been used. So it did reference A this time, so that's why that one is cleared off. But now I have a second one, which again, I know I haven't used yet. So now we want to go and create a third tolerance, and this last one that I'm going to create is going to reference this interior hole, the center hole, and I'm going to select that, and it is smart enough. It knows that it's not a member of a pattern, so I'm going to accept that and place it. And you can see how it's defaulted to the positional tolerance symbol. Before I do that, make any change, I'm going to actually add a symmetric tolerance at the top here. And I can make a change to the value. And I can go also, and this is something that that I wanted to show as a way that you can change your datum reference frame. So initially, I didn't realize that these were all hot, they're selectable fields. So you can see I can hover my mouse over the the datum reference frame that's been assigned for this annotation, and I can select on it and make a change. Right now, if I pull this list down, there is only one that's available, so I actually don't have what I want, so I can create a new one on the fly. So I can go in and say that I want a datum reference frame that's going to be referencing the A and B surfaces, and I can do that, and now I have that, and I can select OK. Okay, so at this point now, I've created my, my next annotation. I do realize, let's say I forgot one thing here, so I want to show you how to make an edit. I can go into this last annotation, right-click, and select Edit Tolerance Feature. What has been toggled off here is the datum feature. I actually do want to create one, so let's say I want to create datum C. So you can just toggle that on and off if you want, and there we go, and so now I have it. So now over in my Tolerance Advisor, you can see that both C and that other ABM datum reference frames are not referenced. Sometimes these messages are pretty cryptic, so you want to figure out what they mean. You can double-click on these, and when you do that, it launches your help utility, and it will identify that what you can do. So here's a little help here. It says, to resolve this message, it's a good practice to delete any unreferenced datum reference frames. Great, so I can just go over into my model tree and hit delete to delete any of those unnecessary ones. I can hit delete, and you can see that it's cleared up those messages. It's not something I need, so I might as well clean them up and have a nice, neat model. I still have one message that is sitting here, and basically it's telling me that some of my surfaces are unconstrained. And how I'm going to clear this one up is using the general profile note. So this is the one I mentioned that is placed on the graphic screen, so I can place it in any of the quadrants. I'm going to place it up here. And what it does is it is specifying my, my general profile note for any surfaces that have not been set with another tolerance feature. And what I can do is it defaults to a value of 0.04, and I can change that value. I can go in and in the Format Text dialog box, I can just select on that field, and then I need to pick this value over here. And then it pops up with a little window that says, okay, you can change this value, and I'm going to go in and change that to, let's say, 0.05, and click OK. And now you can see how that's updated. And with that, the addition of that general note, you can now see that I don't have any more errors listed in my Tolerance Advisor. So great, I'm happy. I can close that off, and I've annotated my model. So that's how you can create, how you can use the mini toolbars to create all of your 3D annotations, whether they're the general ones, whether they're tolerance features, which are the GD&T. It's basically all done through that interface. So at the very beginning, I mentioned that customers would implement something like this for a MBD workflow, or would be looking to share their information in a 3D PDF format. So I just want to flip over quickly to a model that's kind of fully annotated here. You can see that I did more work on this one to add not just the geometric annotations, but some dimensional ones as well, and as well as just a leader text note. And I want to show you how I can share this. So for the MBD people out there that want to share this for downstream consumption by another software program for manufacturing, they're looking at creating step files. So you can go down and you can select the CAD format, save it as a step file, and you can go into the options tool here. And in that tool, you want to be sure that you're picking step file 242 format. And this is a format that supports the model-based 3D engineering. So this is a key selection. If you just select without selecting the options, and it defaults to one of the, I think it's 203, so you want to make sure that you're actually exporting the right type of step file. And you can click OK, and you can save it, and then you can share that step file with anyone. I'm just going to cancel it. I don't need to actually create that step file. And then the other option is this 3D PDF. So I can go in and create a 3D PDF. And it's basically powered by this Anarch Core software, and it enables you to then quickly create that 3D PDF. I'm just going to create a PDF just for quick that only has the isometric design view assigned to it, and I'm going to publish it. I've already created this. I'm just going to overwrite it. So when it talked about design views, this is just like in standard part design. You have the ability to create design views of your annotations. You can customize the way they're laid out, they display, and they oriented, that type of thing. I didn't get into that in this course because I just don't have enough time in 1 hour. That is something that's covered in a whole chapter in our training guide. So definitely if you're looking at sharing with a PDF format, you'll definitely want to look at learning how to do that. And you can see now I have my 3D PDF. So it's created this nice interface with my 3D PDF. I can use all the tools that are available to me to annotate it, review it, that type of thing. So that's how I can share that model. And the last thing I want to show you is for those of you that may want to use those 3D annotations that you created in the part and share them into your drawings. You can open a drawing file. So I just created a very basic layout here with an ISO view of my model. What I can do on this view is just right-click on it, and I select this Retrieve Model Annotations. And basically it retrieves all of the model annotations directly into my view, and I can go through and use this dialog box to kind of filter what I want. So let's say I only want to show all of my, my geometric annotations. I can do that. I can turn off different things, and I can click Apply, and now they're all brought into my drawing. So that's what I wanted to show you. It's definitely lots of stuff, lots of information that is available to you inside of this tool. Before we get to the questions, I just have a couple housekeeping things. I like to always tell my customers that use our books what's available now in 2018. We're doing really well with the release of all of our books. There's only a few left that are coming out this fall. And the one I wanted to highlight was this new book. So this is the one I've been kind of talking about throughout this webcast. This is the Working with 3D Annotations and Model-Based Definition. It covers definitely a lot more than what I've covered today. In it, there's lots of tidbits of great information that you'll want to use if you're going to implement this in your environment. This is available on Amazon, so you can purchase books through Amazon or on our ASCENT eStore. And on the ASCENT eStore, you can purchase this as an ebook or as a hard copy book that would be delivered to you. And with that, I'm going to hand you over to Corrine.
Hello, thank you. That was excellent, Jennifer. It was a very good presentation. And if you would like to hear and see Jennifer present live, then come to Autodesk University. What a great segue. We are going to be at Autodesk University in November, which will be here before we know it. And so will Jennifer and also Michelle Rasmussen. So Michelle was one of our other authors here who's going to be speaking as well. And if you're familiar with ASCENT and how we've done things in the past, we are doing things a little differently. We aren't going to have the bookstore right at the show floor where you come in and you buy your book at a discounted price. Instead, we're moving it up and we're doing a pre-show sale. So you do need to attend Autodesk University to take advantage of this.